This meeting.
Okay, in our previous class, we have seen the spanning tree lab. We have seen electing a root bridge. We adjusted the priorities, and we have seen the root bridge election is changed from one device to the other device based on the priorities that we define. And then we have seen a concept called port channeling. We have seen what is port channel, how do we bundle interface into a port channel. We discussed about modes of the port channel, like LACP, PAGP, different modes of the port channel, and based on those modes, we have seen the load being distributed on both the interface and the port channel. And we talked about LACP and PAGP. LACP is more of like an open standard. PAGP is Cisco proprietary. We have seen that. And we have discussed about different modes of the operating system, like active mode, passive mode, desirable mode, or auto mode. So we have discussed about that. And we also did a small lab. Any questions from our previous class, guys?
No, sir.
Okay. Today we will talk about redundancy protocols at the gateway. So when we have two gateways, if one gateway fails, we should be having a redundancy so that the network connectivity will not be broken completely. So we will talk about different first hop redundancy protocols, and we will see what are the differences between them. Okay, let me start sharing my whiteboard. So the name itself says it is the first hop and it is the redundancy protocol. So let's see what is the first hop mean. So let's say you have so from the PC. So from the PC, we have two uplinks. One link is connected to the switch 1 and the other link is connected to switch 2. So if the switch 1 fails, we have the switch 2 as the backup switch. So we just connected PC1 NIC card to switch 1 and PC2 NIC card, PC1 NIC other NIC card to switch 2. And we have the gateways here, gateway, which is the router 1, and the other router is the gateway 2. So we have 2 gateways. So if one gateway fails, the packet should go via other gateway. For that, what we will do is we will group the gateway 1, meaning router 1 and router 2 in a specific group. And for the PC, we will define the IP address as the group IP. Okay. So from the PC, we will say if you wanted to go outside of the network, you will go to the gateway. The gateway IP, we will not give the router 1 IP, we will not give the router 2 IP, but we will give the group IP, which is also called as a virtual IP. So that the virtual IP will be either sending the traffic to router 1 or router 2, depends on the priority. So we will make one as the active and the other one is passive, right? So when the traffic is coming from PC1 to the switch 1, the switch 1 will be pointing that to the VIP, because the ARP binding, ARP binding will be mapping to the VIP IP, not the physical IP. So now the traffic will be pointed to the VIP IP, and the VIP IP will be pointed to the either router 1 or router 2, depends on the priority that we define for these routers. And this kind of protocol is called first hop redundancy protocol. So if one gateway go down, the other gateway will be acting as the redundancy to take over the path. We cannot afford losing the network for companies. So we will be having the redundancy between the routers. If one router go down, we have another router to fail over the traffic to. Any questions?
Sir, how is it different from load balancer, sir?
How is it different from?
Load balancer.
Load balancer is sharing the load between the servers. So, in load balancer, let's say you have server okay. So let's say I take web server 1, web server 2, and web server 3. So they are all running on the same application. Let's say this is a website of a website, let's say keyboard.com. Okay, this is a web server which is hosting that website, keyboard.com. This is the keyboard.com, this is the keyboard.com. So 3 servers are running the same website on them because there is a lot of traffic and a lot of people trying to use. So what we will put is, we will put a load balancer before that. So this is a load balancer. Okay, and we'll create a virtual IP here. For example, let's say the virtual IP is 1.1.1.1, and the server web server IPs will be, let's say 2.2.2.2, 3.2.2.3, and 4.4.4. So the traffic from the load balancer can go to web server 1, web server 2, or web server 3, but the client, let's say the client is here inside the internet. Client will hit the load balancer IP, which is the VIP IP, and the VIP IP will be pointing to the web server 1, web server 2, web server 3, depends on the load. It can load share accordingly as per the data that the user. So let's say one user is in Chicago. So the user hits the VIP, and the Chicago user can be pointing to web server 1. And other users in New Jersey, they will hit the VIP IP, they might be pointing to the web server 2. there are different conditions on how it can share the load, like round robin, least connection, weighted least connections. So this is a load balancer concept, but we are not talking about that. But what we are talking is, so when we have a PC, that PC has to go to the internet. Okay, so the PC will have a connection to the switch will have a connection to the router, and the router will go to connection to the internet. If this router go down, we need to have one more router. So we will put both the routers or the layer switches into a group, and then if one router go down, it will be failing over. So that is the difference.
Okay, sir. So, so we'll have multiple routers. You mean to say that, but one will be active and one will be like idle or passive, right?
Yeah, one will be active and the other one will be passive. Based on the priority that you give, it will become active or passive. The higher priority will become the active. Okay, so there are three different protocols for this to work out. One is FHRP, FHRP, GLBP. Okay, these are the three different first hop redundancy protocols which are in action. So HSRP and VRRP are very similar. HSRP is Cisco proprietary and VRRP is open standard. Okay, and the namings wise, HSRP is called active standby. In VRRP it's called master backup. Just the terminologies are different, but the concept is very same. So let's look at the concept one more time. So you have router 1, you have router 2. There will be a link between them. Okay, and then you can have this. For ease of understanding, I'm taking one switch. And this will be connected to a PC. Usually on this PC, let's say this PC wants to go to internet, okay? So this router 1 and router 2 will have the connection to the internet. So what we will do is we will put both of them. We'll put both of them in a cluster. Okay, so this is the HSRP group. So there will be a virtual IP or group IP. So for the PC one, this virtual IP or the group IP will be the default gateway. So the traffic will hit the virtual IP. Now the virtual IP is like a virtual router that will be pointing to either router 1 or router 2, depends on the priority. Let's say we define the priority here as 150 and the priority of this one is 100. So this one will become the master, or this will become the active. So the traffic will be pointing to the virtual IP and the virtual IP will be pointing to the router 1 because this is the active, and this will be pointing to the internet. If this go down, this one will take over role of the active. So the traffic will be going to the virtual IP and the virtual IP will be pointing to the router 2 and then going to the internet. Okay. So there is a concept called preempt. Preempt is nothing but, let's say, let's say this one is active and this one is passive. The traffic will be pointing to the VIP group. This will be pointing to the active, and then this will be going to the internet. But if this go down, this one will take over the role of the active. what if this will come back up? When it comes back up, when this router comes back up online, the traffic will be taken over by this active device again because it came online again. So whenever a router go down and when it comes back online, if it has the high priority, that will take over the role of the active. So preempt is nothing but when the primary router go down, if it comes back up online, it will take over the role of the primary. If the preemption is disabled, if the active router go down, when it comes back up online, it will still be passive. It will not try to take over the role of the active again. Whatever the device that is active, that will stay on active if the preemption is disabled. But if the preemption is enabled, if the active router go down, if it comes back up online, it will take over the role of the active. So that is the concept of preempt. Any questions?
So can you please repeat it again?
Let's say we have router 1 and we have a router 2. If router 1 go down, which is the active router with high priority, when it comes back up online again, it will take the role of the active back because it came back up online. Okay. That will happen when the preemption is enabled. When the preemption is not enabled, if this one is active, if this go down, even though when it comes back up online, it will stay passive only. Okay. So to give a real-time example, let's say you have a path 1, you have a path 2. You want to go to a destination. Let's say you want to go to Chicago. Okay. So from here, you have a path 1 via Conway, and you have another path to go via Tennessee. You think that going via Chicago, or sorry, going via Conway, let's say it costs you like $100. But going via Tennessee will cost you $200. Okay. So we have active users going on Conway because it has the lower cost. Let's say this path is shut down, meaning there is a roadblock or an accident. This path is completely blocked. Now the traffic will go over Tennessee path to go to the Chicago. But when this path is back online, when the traffic is cleared, now there is a traffic open to go to Chicago here. If the preemption is enabled, the traffic will now go via Conway to Chicago. If the preemption is not enabled, even though this path is active now, the traffic will still take over Tennessee route to go to the Chicago. Is it clear now?
Sir, is it prevention or prevention?
Sir, is there any way there are like multiple active routers can act in one group?
You want to make active? Yeah, I mean there is a way, but that can be achieved at just like the spanning tree. We are blocking one. We are doing per VLAN spanning tree, right? We wanted to make both are active because we will share for one VLAN. We will put one as root bridge, another one we will put other as root bridge. Do you remember that concept?
Yeah. So and here also the priority dependent for the route or
Yeah, here also priority can be defined per VLAN level. So one VLAN, your router 1 can be active, and another VLAN, your router 2 can be active, so that you can load balance the traffic between both the routers.
okay, got it.
Just like per VLAN spanning tree, you can separate them based on the VLAN, you can apply the priorities.
Yeah. Okay. Yeah.
Just like in the spanning tree, we have per VLAN spanning tree where we apply priority and make use of all the routers in the path. Similarly, we can separate our VLANs into groups and we can apply the priorities per VLAN so that we can have both the routers acting as the active and active. Okay. Now in VRRP also, the concept is very similar. There is no change. Like I said, the terminologies are different only, just for us to understand. This one will become the VRRP group. Here the active one will call master. The secondary is called backup. So the traffic will be pointing to the VIP IP, group IP, and that will be pointing to the physical interface of the master device. And if the master fails, the traffic will be pointed to the group IP, it will be pointed to the backup router and reach out to the internet. Okay. So here also in VRRP, there is a concept called preempt again, same concept. The traffic will always try to go to the active. If the active fails, the traffic will go to the backup. If the master comes back up online, the traffic will go to the master and then go out. But if the preemption is disabled, the traffic will still go to the backup and then go to the internet because preemption is disabled. Okay, VRRP also supports the VLAN load balancing. You will apply per VLAN where you will put one VLAN active with high priority and other VLAN you will put other router as the priority. So that you can have the load sharing of the traffic per VLAN for the VRRP as well. Okay. Is that clear, guys? Are you able to follow me?
Yes, sir.
Yes, sir.
Okay. And the third one is GLBP, guys. GLBP is a little different because GLBP concept is different because in HSRP and VRRP, we were able to load balance only at the VLAN level. Okay. But GLBP will provide per packet load balancing. So let me explain what it is. Okay. Let's talk the disadvantage of the HSRP or VRRP before we go to the GLBP. So there is a switch. PC1, PC2, VLAN, let's say this is in VLAN 10, and this is VLAN 20, and this switch has a connection to okay. So as I told you, we can separate the priorities at the VLAN level. So on this gateway, we can do VLAN 10 priority as 150 and VLAN 20 priority as 90. Okay. Here VLAN 10 priority is 100. VLAN 20 priority is 200. Okay. So from this setup, we know the PC1 traffic should point to the virtual IP of the group. And because VLAN 10 has the high priority here, the traffic should go to the router 1. If the traffic is generating from PC2, the traffic will be pointing to the group IP, and this should be pointing to router 2 because it has the VLAN 20 high priority here. And this PC in the VLAN 20 and this PC in the VLAN 10. But if you observe, we are not load sharing the traffic between this link and this link for VLAN 10. We are only load sharing at the VLAN level, not at the PC level. If this PC wants to use both the routers, it cannot use it because VLAN 10 is always priority higher on this one, VLAN 20 is always higher on this one. So we are not doing the per host load balancing in the HSRP or VRRP. Whereas in GLBP, we can do per host load balancing. It is not prevention, it is called preemption. PREEMPTION. I'll put that in the chat for everyone. Someone asked me a question. Is it prevention or prevention? It's none of it. It's preemption. Let me write it down here, the word. Okay. So what I'm trying to say here is, so we are only load balancing at the VLAN level, but at the host level, we cannot load balance the traffic for both this one and this one. So the GLBP solves that problem. We can do load balancing per host or per device that can be achieved by GLBP. Okay. Is that clear, guys?
So what if both the VLAN values are same, like both are equal? Then how does it do?
You mean the priorities?
Yes, sir.
If both the priorities are same, in spanning tree, what happens if both the priorities are same?
We'll see the least MAC
Yeah,
address.
Yeah. So
access.
in spanning tree, we will choose the lowest MAC address. Whichever has the lowest MAC address, that becomes the root bridge. Similarly, if the priorities are same here, it will choose the highest IP address. Whichever has the highest IP address, that becomes the active, and the lowest IP address will become the secondary or passive. Okay. So let's see GLBP, how it works. So just like HSRP or VRRP, we will create a virtual gateway for the host, right? So, but GLBP can do load balancing without the VLAN level, but it can do the load balancing at the host level. Okay, so to do that, let's take a topology. Okay, so again, we'll take a PC, this one PC here. So here from the PC1, you will put the default gateway, your gateway as the GLBP virtual IP, which is the cluster IP or the group IP. So the traffic comes here. Now the virtual IP will point to the either router 1 or router 2. That can be done using the election of AVG and AVF. AVG and AVF. So here the routers like R1 and R2, they are in the same group, right? So they will elect AVG, which is the active virtual gateway. So the role of AVG is to assign a virtual MAC addresses to all the devices running the GLBP. So this AVG role is to assign the virtual MAC address to this router and also this router virtual MAC address. So when the traffic is hitting the GLBP virtual IP, the ARP resolution will be pointed to this virtual MAC address one time. And when the next packet comes into the group virtual IP, it will point to this virtual MAC on the second time. So it's like sharing the load per packet between the AVG and AVF. Okay. If you take off these terminologies, think about like if you have two devices, if you want to go to some destination here, you will be pointing to the group name. The group name will be pointing to sometime the physical name of this device, and sometimes it's point to the physical name of this device, and then it will make you to go to the destination from both sides. So the whole concept is not just always pointing to the one device. It will point one time to this device and another time to the other device, so that it will share the load between both of the devices. So if you understand the ARP what will do, it will bind the IP address to the MAC address. That's what we learned. What does ARP do? ARP will bind the IP address to the MAC address. So when the PC is looking for the gateway, which is the gateway IP address, the gateway IP address will always point to this R1 MAC address or R2 MAC address. That is the functionality of AVG that we'll be doing. And AVF is a forwarder, which will just listen from the AVG perspective. So that is how we can do the load balancing between both the routers with the concept of virtual MACs that are defined on the AVG and AVF, so that we can do per packet load balancing. Any questions on this topic?
What is the full form of AVF?
No,
AVF stands for Active Virtual Forwarder. Oh, it's AVF. There are different types of load balancing here. We can do round robin load balancing, or we can do weighted round robin, or you can do like host dependent round robin. So let's discuss what kind of load balancing it can be achieved. Load balancing methods it can be achieving. So let's talk about them.
sir, what is packet?
I'm sorry.
What is packet?
What is packet?
Yeah.
Packet is nothing but a terminology. We call it on the layer 3. In physical layer, it's called bits. In data link layer, it's called frames. In network layer, it's called a packet.
Okay.
When you attended the first class in the OSI model, we talked about packet. That's an interchangeable term. In every layer, we call it separately. But because we mostly focus on network layer, that's why we are referencing them as a packet. But packet is nothing but data that is being sent from PC to the source to the destination. If
Okay, sir.
let's say you wanted to send me a file over the Gmail, you are
Yeah.
sending packets to me, but it's application layer, it's called mail, but in network it's called packet. Anything we consider packet is nothing but the data.
Okay, sir.
Can you explain once again AVG and AVF, sir? No, not the operation, like work done by both AVG and AVF. How exactly that load balancing happening based on AVG and AVF?
AVG is the active virtual gateway, which is the deciding factor of assigning the virtual MAC addresses to all the devices in the group. When the AVG is elected with the high priority, the traffic from the PC will be pointed to the virtual IP. Let me change the color. The traffic from the PC is connected to the virtual IP. So now this virtual IP should be pointing to a MAC address. So the AVG will assign the virtual MAC address of router 1 and router 2. Now AVF is just a forwarder, right? So when the packet PC comes to the group, it can either point into the AVG or AVF, okay? But AVF will just forward that, but AVG will also assign the virtual MACs to both the routers at the initial stage.
Okay, sir. So AVF, if the packet is directly coming there, like AVF directly forward without any load balancing, you mean?
No. AVG is the one which is electing the virtual MAC addresses of both the routers in the group. That is the role of AVG. AVF doesn't do any election of MAC addresses, it will just forward the data that it comes to it.
So definitely the data will come from the switch only, right? It can't be go directly, right?
No, I mean, it has to come to switch, but I'm talking about it's pointing to the group IP.
Okay, so it is only forward the IP, but it will not do anything.
What do you mean by forwarding the IP? I'm not following the question.
AVF, that's what.
AVF will not elect the MAC address to both the routers, virtual MAC. AVG will elect either the traffic should point to AVG or AVF. At the initial spot, the AVG will do the action, right? So let me make this clear. Maybe you guys are getting confused. So let's do one thing. So this is router 1. This is router 2. This router 1 has a physical IP address. Let's say this has 1.1.1.1. Okay. And this router 2 has a physical IP address as 2.2.2.2. Okay. So these both are in a group. Okay. And the group IP is 10.10.10.10. Okay. So now this router and this router will talk between them. Whichever has the high priority, that becomes the AVG. So the other one will become the AVF. Okay. Until this point, are you guys clear?
Yes, sir.
Okay. Now, when the PC sends the data to this IP, the group IP, AVG will decide whether the traffic should go to router 1 or router 2. Okay. So the AVG will decide the group should either point the traffic to router 1 or router 2. That is the role of AVG. But once the packet comes to the router 2, the router 2 will forward the data to the outside. Is it clear now or no?
To come to router 2, that AVG only is decided. AVG itself is deciding to come to router 2, right, sir?
AVG will decide whether the traffic should come to router 1 or router 2. Yes.
for every packet of data coming, so AVG is itself doing the doing the decision making whether it go to R1 or R2.
Yes.
So on what basis it?
I don't know, guys. It's completely looping for me. Please, if you are looping, you can put the text in the question chat.
On what basis AVG decides to choose the router?
It can depend on different load balancing methods. It can be a round robin or a weighted round robin or a least connection. You can have different methodologies on decision. You can decide as an engineer, you can decide the basis on if you want to put like round robin, you will put one packet to this one, another packet to this one packet to this one, another packet to this one. It's like sharing. Let's say you're playing a card game. You share the cards equally to all the players, right? If you're playing rummy, you will start the deck. You will give the first card to the first player, second card to the second player, third card to the third player, and then you rotate accordingly until you complete the deck, right? Similarly, when the packet is coming in, it can go first packet to this router, second packet to this router, or third packet to this router, fourth packet to this router. It's equally sharing the load of connections between both the routers. That can be one use case. That is called round robin. So that is one of the mechanism of algorithm. Is that clear?
One doubt, sir. Sir, it's coming from AVG itself in the router space, right, sir? In the R1, R2 is there in that zone, AVG is defined, right? So when a data is coming from the switch, how it is going to decide I will go to so you said like AVG is going to decide whether the data should go to R1 or R2. But it is coming from the switch. How it is going to consider whether I'll go to R1 or R2?
How does the switch send the data to the router, guys? Based on the ARP table. ARP table, right?
Yeah.
Right. So when the switch is sending the data to the group address, the ARP table will point to the virtual MAC that is defined by the AVG.
Okay, the data going to the before to the R1, the AVG will be separately there, right, sir?
So are you guys asking me like, is it a physical component or a virtual component? Is that what your question is?
Yes, sir. Because you said the R1 and R2, AVG will be in the R1 itself, right? That's what we are confused
Based,
with.
see,
Yeah.
in the HSRP or VRRP, based on the priority, that becomes the master and standby, right?
Yes.
Here, the priority high becomes the AVG.
Okay.
Okay, so you tell me then, if there is only one router, if there is only one switch, if there is only one PC, how does the switch send the data to the router, guys? Let's not take two routers here. I took one PC, one switch, one router. How does the switch send the data to the router? How?
By binding the IP address to the MAC address.
Yes, by binding the IP address to the MAC address. So switch is pointing to the MAC address of the router. It will just send that to the router IP address, which is the gateway. That is called ARP. Here also there is a switch. Let me change the color. Here also there is a switch. The switch is pointing to the group IP, and the group IP will be pointing to the either R1 MAC address or R2 MAC address. That will be decided by the AVG. The AVG will be continuously communicating with the group, and based on the resolution, it will point to the MAC address of the router 1 or the MAC address of the router 2.
So one of the router will act as the load balancer continuously, sir.
One of the router will be deciding which router it should go, whether it should come the packet to it or it should go to the packet to the other router. You can, I mean, in a gist of terminology, you can call, yes, it can act as a load balancer. It will decide whether the packet should come to it or not.
Yeah. So is there any real-time scenario where we use this protocol, like in e-commerce or something?
I mean, any network, if you want to use both the routers without having one sitting idle, if you wanted to share the load on both the routers, then you can use GLBP. Let's say, let's take an example then. If you have a router 1, you have a router 2, you have one connection to the internet. Let's say you purchased AT&T internet connection. You're paying $1,000 AT&T bill every month to go to internet. And you have another connection, Verizon, and you have internet connection. You're paying $1,000 bill for it. You have a switch. Your PCs are connected here. Your PC is connected to the switch. Your switch is sending always the traffic to the router 1, always to the router 1 to go to the internet. Then why to pay $1,000 every month just sitting it idle? It is important that you load share the traffic to both the routers so that you are using Verizon and AT&T and making use of $1,000 every month, right? Why to waste $1,000 and sitting it idle?
Yeah. So it depends upon the volume of the request we are doing, right?
Yes, exactly. It depends on how much scalability you want on your network or how much positively that you want to use your network. You want to sit one as network as idle and put all the load on the one AT&T device, or do you want to load share?
Got it, sir. Yeah.
So the different types of load balancings are, like I mentioned, we have round robin. We can have host dependent, or we can have weighted round robin. So like I said, in the round robin, it's like a round table. You have a table of users. You have one user, another user, and you have another user. You send one connection to one user, another connection to other user, another connection to another user, and repeat the same thing and rotate in a round table fashion. That is round robin. Similarly, for router 1 and router 2, you have a switch, you have a PC. The traffic goes from one router, first packet, second packet, third packet, fourth packet, fifth packet, like that. You're alternatively sharing the packets. That is the round robin. Host dependent is separate. So for example, you have PC1, PC2, you have a switch, and you have router 1, router 2. So PC1 traffic always go via router 1 and go to the internet. PC2 traffic always go via router 2 and go to the internet. So based on the PC IP address, the traffic will be shared. So if the PC IP address is 1.1.1.1, you can send that traffic to always via router 1. Similarly, if the PC2 IP address is different, 1.1.1.2, then the traffic will always go to this router. So based on the IP address of the host, the traffic can be shared between both the routers. So it depends on the host IP address, we can change. So we can do the host dependent load sharing. And the weighted round robin is, it is very similar to the round robin, but it is weighted, meaning, so if you have 3 users again in the deck, you are not equally sharing the load, but you are giving weight. For example, you will send 2 packets to this user, 1 packet to this user, 1 packet to this user, and again 2 packets to this user, 1 packet to this user, 1 packet to this user, again 2 packets to this user, 2 packets and 1 packet to this user, and 1. So you are putting 2:1:1 weight, right? So you are sending 2 packets to this user, 1 packet to this user, and 1 packet to this user. Similarly, you are sending 2 packets to this router, 1 packet to this router. Again, 2 packets to this router, 1 packet to this router. So you are sharing the load as per the weight, not per packet load balancing, but you are sharing the load as per the weight. With different weights, we are forwarding the traffic to the router, depends on the capability. So why we do this? Let's say this router has a big internet connection. Let's say this has 10 gig internet connection, and this router has only 1 gig internet connection. You are paying $5,000 internet connection for this one. It has high capacity, but you are paying only $1,000 here. So you want most of the traffic. You want most of the traffic should go via this router, but only some of the traffic should go via this router. Then you will do the weighted load balancing between both the routers, because you have high capacity on this router and this internet connection compared to the other side. That is how we can apply the load sharing with the GLBP. Okay. Any questions, guys?
Sir, in this case, does the routers communicate with each other?
They have to, right? They have to communicate. Otherwise, how will they know which one is primary and which one is secondary, which one is AVG and which one is AVF? There has to be a link between them to communicate between them.
Okay, okay, sir.
Tomorrow, when we do the lab, you will understand the configuration piece.
Sir, will there be only one AVG or there can be multiple AVGs?
Why do we need multiple AVGs?
So load distribution can be done through only one AVG, right? Then, yeah, we don't need. Yeah. Okay, sir.
Yeah, guys. So to do per packet load balancing, we do GLBP. But if you wanted to do at a VLAN level load balancing, we can do HSRP or VRRP. Okay. All right. Any other questions, guys?
No, sir.
Okay, and tomorrow when we start the class, I'm going to take these 2 routers. We'll put a switch on a PC, and then we'll configure the HSRP or VRRP between both. I mean HSRP, and then we will see how the traffic is flowing between both of them. Okay.
Ravi sir.
Yes.
I just have one query. Like, I just saw the text message of directors are in a group regarding the mock sessions. There is any specific time for each student, or we just need to directly contact with the Pawan sir?
Can I stop the recording 1 second, please?
Yeah, sir.